Today, on how it's made. Solid tires. A factory where they set the wheels in motion. Cheesecake. This is no half-baked idea. Canoe paddles. They're made for a quiet glide. And globes. At this factory, they're always on top of the world. The solid rubber tire is designed for off-road conditions, as in construction sites, landfills, and warehouses. These areas are full of hazards that would flatten ordinary air-filled tires. But solid tires don't go flat. They just keep on turning, and that's a good thing on any job site. No air in these tires means they're ideal for heavy work. They can move a lot of weight around without buckling. They start with a wide flat strip of partially processed rubber. A hot extruder forces it through a series of holes. This transforms the rubber strip into a narrower, rounder form. The rubber falls between hot cylinders. They roll it thin and soft like pie crust. In another part of the factory, they prep metal framework for the tires. A worker moves them along an overhead rail into a special chamber. He shovels in steel pellets. Inside the chamber, a machine tosses the pellets about and the friction polishes the metal tire frames. They spray on a coat of primer and apply an adhesive. Next, they mount one on a mechanical arm that's positioned in front of the rubber rolling system. The arm moves the tire frame forward to meet the turning cylinders. The surface, still tacky from the glue, takes up the freshly rolled rubber. It layers the rubber around the tire base up to 100 times, depending on the tire being made. Then they weigh it and slice off bits of rubber until it meets specifications. This solid tire is now in good shape, so it moves on to the next stage. Over at another station, they're building another type of solid tire with no metal framework, so it will fit on a wheel rim made for an air-filled tire. They wind rubber strips around a metal hub that serves as a mold. A bar presses down on the rubber wrap to eliminate air pockets. These rubber strips contain recycled material, which is stiffer. This will help the tire hold its shape in the absence of a metal framework. These tires need some tread. They begin by spraying a release agent onto a mold so it will be easier to remove the tire later. Then they lightly glue the ID label and serial number plate to position them for transfer to the tire. They center the tire in the mold with a metal ring. Then they lower the top section of the mold onto it. They now hoist the mold to another station, where they sandwich it between two steaming hot plates. The hot hydraulic pressure melts the rubber into the crevices of the mold. The rubber cures in minutes, and they open the mold to reveal a treaded tire. The process has also vulcanized the rubber, a molecular change that strengthens it. It takes a specialist to change one of these tires. He travels to the work site and, using a hydraulic system, he removes the old tire from the wheel rim and installs a new one. And that's how you put a solid tire on a wheel rim made for an air-filled one. Big tires with metal framework go into this autoclave to take shape and undergo vulcanization. A forklift, equipped with solid tires, of course, extracts the finished tires from the autoclave. And now, they're ready to roll. People associate cheesecake with New York, but it actually comes from Greece. The ancient Greeks served cheesecake to the athletes of the first Olympic Games in 776 BC. The Roman conquest spread the dessert across Europe, and many centuries later, European immigrants brought it to North America. The ancient Romans brought cheesecake to their temples as an offering to the gods. The cheese in cheesecake can be cottage, ricotta, Neuchâtel, or cream cheese. Their base, a butter cookie crust, similar to shortbread. For a batch of about 5 dozen cakes, this bakery combines 23 kilograms of butter with 4.5 kilos of sugar. Next, 16 egg whites, then 11 kilograms of flour. After mixing just long enough to incorporate the flour smoothly, the dough is transferred via conveyor belt to a vat. Gravity pushes the blob of dough out through a slot at the bottom, expelling a dough sheet about 0.5 centimeter thick. A dusting of flour prevents the dough from sticking, not just to the conveyor belt, but also to the rolling and cutting tools. This prickly roller perforates the dough sheet. The holes enable trapped air to escape during baking, which prevents the dough from shrinking and ensures a flat, bubble-free crust. The next roller has plastic circles that work like cookie cutters, slicing the dough into cake-sized discs. The leftover pieces go into new batches of dough. Each dough circle goes into a pan, then bakes at 190 degrees Celsius for 16 minutes. Meanwhile, the batter takes shape. For a batch of about 20 cakes, the bakery combines 11 kilograms of cream cheese with a kilo of cultured sour cream. That's sour cream processed a little longer than usual to give it more flavor. After slowly mixing in 7 kilograms of sugar and about 2.5 cups of flour, they blend in 3/4 of a cup of vanilla extract. Now they get cracking with 1.5 dozen whole eggs. That's the recipe for plain cheesecake. Flavored versions contain extra ingredients. This batter is caramel pecan. It goes with a chocolate cookie crust. As the baked crusts arrive, sprayers grease the inside of each pan with butter so that the cake will slide out easily after baking. Then a machine called a depositor shoots in just the right amount of batter. The pans now enter a tunnel-shaped oven that's 21 meters long. The temperature inside is 177 degrees Celsius. By the time the cakes exit at the other end, they're fully baked. These 25 centimeter wide cakes take just under an hour. From the oven, the cheesecakes go onto a cooling conveyor. By the time the hot cakes, up to 2,000 at a time, do the nearly hour-long circuit, they're at room temperature and ready to come out of their pans. From there, it's straight into the storage freezer, except for certain cheesecakes, which detour to the decoration department. There, this Belgian chocolate cheesecake gets a big squirt of chocolate ganache, a decadent mixture of chocolate and cream. Workers spread it all over, then make swirls with a decorating comb. And now, the final touch, a sprinkling of cocoa. Certain orders go into an automated cutting machine that divides each cake into 14 equal slices and inserts parchment paper in between them. Back at the decorating department, they're putting shards of chocolate on a mud pie, a combination chocolate souffle, chocolate cheesecake with pecans and a coffee mousse topping. You might want to put off that diet just one more day. Paddles keep us from going adrift, and no one wants to be up the creek without one. Paddles have been around so long that who invented it or when isn't really known, but there's no question that paddles have evolved. Made with sophisticated craftsmanship, today's wooden paddles really go the nautical mile. With paddles like these, you can really go far. Talk about upstream mobility. These days, paddles are often a blend of hard and soft woods for a result that's strong yet lightweight. They feed the boards to a multi-bladed ripsaw that slices them into uniform strips. Each strip has a flat, smooth joint on the side. They roll glue onto those flat joints and then press the strips together. These glued sections will be used to make paddle blades. Over at another station, they're working on the paddle shafts, 2 at a time. They glue shorter pieces of wood for the handles and clamp them together to allow the glue to set. They arrange the blade chunks in a much bigger clamp. Then they wedge the glue-coated ends of some shafts between the blade pieces. In a process called lamination, the blades are bonded to the shafts. The laminated paddle shapes are called blanks. They pencil the blade design onto one of the blanks, and they cut out the design with a bandsaw. Laminated wood doesn't warp easily, which means the paddle blade can be made wider to give more power to the user. But paddles cut from a single piece of wood have a more traditional look and feel and are favored by some. They cut this narrower paddle from a piece of cherry. Modern tools make quick work of a design that hasn't changed very much over the centuries. In no time, they have a basic paddle carved from a single piece of wood. They round it off with a large router. It shapes and contours the paddle to its final dimensions and gives it a smooth finish. In just minutes, that chunky-looking paddle is transformed. Meanwhile, back in the laminated paddle department, a saw cuts slots in the tips of each one. They mix up a liquid plastic concoction, then pour it into the slots where it hardens. The plastic gives the paddle tips some extra protection against rocks and other obstacles in the water. Now it's time to improve the profile of the laminated paddles. With the same type of router used to shape the solid paddles, they fine-tune the design. Both types of paddles then get a heavy sanding. They taper each one so it's much thinner at the tip. They brand the trademark information onto each paddle using a hot iron. Then it's time for the paddles to take a dip in a tank of varnish that contains a sunblock. The varnish both protects the wood and enhances its natural beauty. They suspend the paddles on an overhead conveyor, and soon they'll be on their way to a waterway near you, where they'll be sure to leave ripples of approval in their wake. Because the world is round, flat maps don't give us the full picture. A globe is the most accurate map of the world because it depicts countries in true spatial relation to one another and better defines lines of latitude and longitude. Globes really give us a well-rounded view of our planet. At the Globe Factory, production revolves around world events. As war and political upheaval redraw boundaries, these spherical maps are revised accordingly. To make a globe, they start with a big roll of cardboard. A machine pulls it under a roller that coats it with glue. A knife then slices the cardboard into smaller pieces, which will serve as liners for the maps. One more coat of glue, and then they stick the liners to the back of maps of hemispheres. Heated rollers press them together, completing the seal. Each map is of a hemisphere, and the printout fans out like a pinwheel. A powerful press now cuts the maps along those lines. They position each map carefully in the cutting press. After all, one false move, and they could lose parts of Japan. It takes 2 punch cuts to do the job. They pull away the excess paper from between the 12 spoke-like sections of the map. Here's a top view of that cutting press. It acts like a giant fist to punch out the map pinwheels. And now, it's time to shape the world. They place a map cutout and a separate liner in a mold of half a globe. It rises into a heated cavity and presses them into a bowl-like shape. Now they have a hemisphere. But of course, there are 2 in every world. They make the southern hemisphere with the same type of mold. The molds also emboss each map to signify peaks and valleys on the Earth's surface. Here's an inside look at those molds. The raised and indented sections of the molds make impressions on the globes. They'll allow people to see and feel variations in the world's topography, both above ground and underwater. The hemispheres are now complete, and it's time to go global. They spin a northern hemisphere, while a razor blade trims the edges. Then a lower hemisphere goes for a spin, while a nozzle beads hot glue along the inside. This stiff cardboard ring adheres to it and gives the hemisphere some reinforcement along the equator. They apply glue to the northern hemisphere, and it fits over the ridged edge of the southern one. They precisely align the 2 halves, and then they tape over the seam. This both disguises it and marks the equator. Next, they mount each globe on a pedestal that's attached to a metal arc called a meridian. Suctioned to the top of the globe, the meridian will allow it to revolve. From fragments of paper and cardboard to a globe, this world was made in just a couple of hours. Globes tell us where we are in the world and help us figure out where we're going. Globes come in many different languages because there is, well, a worldwide demand for them. And because they help us get our bearings, you could say they make the world a better place.